Hello. Welcome to this evening's TI Technology webinar hosted by Texas Instruments, where we will take a look at how some of the changes and shifts in the TEKS content standards can be enhanced with TI technology. I see that many of you are joining us for the first time, so we'd like to offer a special welcome if this is your first T-Cubed Professional Development webinar. We'd also like to thank everyone for completing the live survey on the right side of your screen. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all students. I'm very happy to introduce our two panelists for tonight, Toni Norrell and Michelle Rinehart. Toni has over 25 years of teaching experience from 5th grade to college algebra. She is currently a math specialist and T-Cubed regional instructor. Toni was also a PAE MST winner in 2007. Thanks for being with us, Toni.
Thanks, Mike. I'm glad to be here.
And Michelle studied mathematics, physics, and education before moving to Texas. Michelle has taught high school math and science at rural districts in Texas, while also working as a math and science consultant. Her interests include technology integration, conceptual understanding, and curriculum and instruction. Michelle has presented at numerous state and international conferences and was named one of the 3 finalists for the 2013 TCEA Texas Teacher of the Year. Thanks for joining us, Michelle.
Thanks, Mike. Great to be here.
We're expecting a large crowd, so your audio is muted. Feel free to send questions to all panelists using the Q&A window on the right side of your screen. We'll also send general messages in the chat window. It looks like a few of you are already really chatting up a storm, and that's great. I do want to mention that a lot of your chats I can't see because I think you're chatting to all attendees. So whenever you have a choice of sending to, it looks like a default is all attendees, but you want to change that to all participants. So when using the chat window, go ahead and chat to all participants, and that way everyone, Michelle, Toni, myself, and everyone participating can see those chats. They're really important to us. This session is being recorded, and as a reminder, we'll provide a link to the event's certificate of attendance at the conclusion of the webinar. Once the recording is available, if you'd like to follow along with your handheld or software, and we really hope you will, we do recommend doing this with the recording. That way you can download the activities and then pause and rewind the recording as necessary. We don't expect you'll have any audio issues tonight, but in the event that you do, try selecting Communicate in the WebEx menu, choose Audio Broadcast, and then click Join. At this point, Toni is going to discuss our agenda and expected outcomes.
Thank you, Mike. I want to welcome everybody to tonight's webinar. We're going to look at the TEKS shifts in middle grades and in Algebra 1, focusing on the content that's new to those grades. We know that we're implementing the revised TEKS this year in the middle grades from K through 8, and we're going to focus on 8th grade, and then we'll be implementing the new TEKS in Algebra 1 next year, but we're starting to look at those now. And so we're going to look and see how TI technology can support this transition, and we're going to look at some specific activities on functions, correlation coefficients, solving systems of equations graphically, and then characteristics of quadratic functions. And we'll end with some free resources from TI. Our expected outcomes for this evening: we're going to identify and use TI activities that provide opportunities for students to use both the TI-84 or the TI-Nspire technology as tools to deepen their understanding of mathematics, be more aware of the content and shifts in TEKS middle and high school mathematics, and stay in touch with social media and upcoming events.
Thanks, Toni. I just wanted to show everyone where you can find these particular activities and literally hundreds of others. If you go to the website education.ti.com and then click on the Activities tab, you'll see there's a number of options under that tab. And two of our favorites are Math Inspired if you're using the TI-Nspire at your district. And if not, if you're using the 84, you can go to TI Math down below, and from there you can search in a number of ways. Another option is to go to Activities and then to actually choose that first option, All Activities, which will let you search by a number of different means. So this is what you'll see when you search by All Activities. And you'll notice that on the left, it has a number of different, there are a number of different ways that you can search. You can search by subject, keyword, standards, and you will find our new standards in there for Texas. You can actually search by textbook as well. So as your new instructional resources come in, you can search by specific sections in those textbooks. And for each of these search options, you can find specific activities that align to those search criteria. So say you're thinking about a new standard that you're wondering, what would that look like? Or what kind of activities are already written for that standard? You can search for that standard and find all kinds of correlated activities for that. So we wanted to start by kind of showing you where the activities that we chose came from and where you can find them and literally hundreds of others. So say we searched by keyword and we were searching for a particular activity, maybe one of the activities we're going to do tonight called function or relation. So once you find that particular activity, you'll have a page like this. And so on the left, you'll see an arrow kind of showing the title of the activity where it says function or relation. You'll see some screenshots and an activity overview to kind of give you a feeling for what this activity is all about. But then on the right-hand side, there's all kinds of really helpful stuff, as you see noted by the arrows. So you'll see teacher notes files in a PDF format, sometimes also in a doc format. So those will be your key, your setup instructions, some different tips and tricks along the way, or other button pushing type ideas as well as instructional considerations. And then the student file will always come in a doc version and a PDF version. And we just love that it comes in a Microsoft Office doc version because then you can go in and make edits. You could change the wording, you could insert additional questions, things like that. So you'll find that on the right side as well. And then the very last thing, the dataset.axp, this is just an example of sometimes there are files or programs that correlate with an activity. And so you're going to find that on that activity page as well, and then you can download that to your computer and from there transfer it to your calculator, whether that's an 84 or an Nspire. And the file type will depend on what calculator the activity is set up for. So I just wanted to show you that site, education.ti.com, to show you where you can find these particular activities and many others. And at the conclusion of tonight's webinar, Mike will share a file with you that has hot links to all of the activities that we're doing tonight together. So you don't have to write them down and try to go find them yourself. You're going to have a one-page document that links to all of those, but there are many, many others, and so we wanted to mention those as well.
Okay, thank you, Michelle. We're going to start off with a grade 8 student expectation that is brand new. 8.5G, identify functions using sets of ordered pairs, tables, mappings, and graphs. This is also a readiness standard. And so the focus of identifying functions, it gives them an opportunity to deepen the understanding that was started in earlier grades of input-output tables and multiple representations. And students should also be asked to explain the definition of a function. And they may be asked to distinguish between relations and functions. So this is going to be an important standard for 8th grade this year. Let's look at some of the activities that we're going to look at related to functions. So we've got two activities that we're going to look at. One is on the 84, function or relation, and the other one is definition of functions, which will be on the Nspire. And as we look at these, Michelle's going to guide us through some of the things in these activities. We're not going to go step by step through each of these activities on the 84 and the Nspire. and we're not going to focus on the basics with these with the calculator or the Nspire handheld, but we're going to highlight specific skills that we feel like are good to know, that may be new with the new content and maybe new ideas to do on the calculator. So Michelle's going to give us some highlights from each of these activities.
Thanks, Toni. We're going to go ahead and I'm going to start sharing my desktop. And so what that means is you'll see the screen will change just a little bit here. And across the top, you may need to go down, go up to the top and click down to be able to open up your chat window again and your Q&A window over on the right side of your screen. So I'll give you just a minute or so to kind of get those back showing. And while I'm sharing my desktop here and kind of walking us through some different activities, Toni will be overseeing the chat and the Q&A window. So feel free to ask questions along the way or share feedback or other ideas, and Toni will interject those comments as well for us to talk about. So again, hopefully you had a chance to turn on your chat and also your Q&A from the top menu. And the first activity we're going to look at is an 84 activity called function or relation. And so I just wanted to kind of give a bit of the overview for how this activity is set up. So in this particular activity, there are 3 different problems, and we're going to work through one together and then maybe just kind of mention one of the other 2. So the first problem deals with voter data, and is there any kind of predictable pattern between what party you voted for in one presidential election and what party you voted for 4 years later in the next presidential election? And so in this particular activity, we're looking at the student activity or part of the student activity. So when we were on that education.ti.com page, this is where you could download the student activity on the right-hand side. And so you'll notice here that kind of walks students through the setup of how they're going to go in and do a setup editor to get a couple lists set up in their stat plot, and then they're going to create a stat plot or create a graph, a scatter plot with the data comparing what percentage of people in select states voted Democrat in 1980 and then what percent voted Democrat in 1984, and is there a relationship between those 2 variables. So kind of some detailed steps here in terms of how to set up the plot and what students need to do there. So then what we're going to look at is, okay, so once we have our stat plot set up, how do we determine whether or not this relation or this relationship is a function or not? And so again, this is new to 8th grade, a new 8th grade standard. And the definition of a function discusses that for every input value, for every x value, if you will, there can only be one output value, one y value. And so we're going to look at 2 ways that we can use both graphs and tables on the 84 to determine whether or not a relation really is a function. So I'm going to go over to my 84 emulator, and you'll see here I've already worked through the first few steps where I've gone in and set up my stat plot. And so we've got percentage voting Democrat in 1980 on the x-axis and then 84 on the y-axis. And so what we want to look at now are 2 different features, maybe lesser known features of the 84 that we can use for determining functionality. So one of them is, since for every x value, we should only have one y value if this is a function, we can use what's called the vertical line test and draw a vertical line on this graph and kind of move it left and right to determine if for every x value there really is only one y value. So how we'll do that is on our graph page, we'll go ahead and use the draw menu. So that's going to be second program. And then within that draw menu, we'll notice that there's a command called vertical. So I'll go down to the 4th option there, vertical, and push enter. And when I add that vertical line when I'm on the graphs page, I can now arrow left and right to move my vertical line across that graph. So I'm, in essence, doing a vertical line test using this vertical line. And what I'm trying to figure out is there ever an x value where I maybe have 2 overlapping y values? So for example, as I move to the left here, it looks like at this particular point there was just, or this particular x value, there was just one y value, this one down here. But over here more to the right, right about here, it looks like I maybe had 2 that lined up, 2 different y values. And so if that's the case, if for this particular x value I actually have two different y values, that would tell me that this relation is not a function. So we can use that vertical line drawn on the graph to help us do an informal vertical line test. Now, when you were looking at big data sets like this, or kind of messy data, it's hard to tell, like, were there really 2 points there over here? Did those really line up? Were those different points? And so maybe we want to look at a different representation where we're really looking at the actual numbers. So for example, maybe I want to look at my table of data. So my table, since I've done a stat plot, is in under my stat menu and then number 1 for edit. So these are all my data points, Dem 80 and then Dem 84, and these are percents who voted for the Democratic Party in particular states. So here I can kind of go through, and here are all my raw data, but if I think about what I'm looking for, so what I'm wondering is, are there any times when the x value, say 48.7, is repeated, shows up twice in this table, but with different y values? And so that's going to kind of be hard to determine from how this is set up. So like I could go and search for 48.7 in this whole long list, and then say I don't find a match of that. Okay, well then I could go and search for 30.1 in this whole list and see if it repeats. So that's kind of tedious. And so another thing we want to look at is, well, maybe there's a way that I could sort this data so that it's already in numerical order, and then I could just go down and look for repeated values of x. And so that's another thing that the 84 can do that we wanted to model here tonight as well. So to do that, I'm going to go to the home screen. So I'll do second quit or second load to get back to the home screen. And then the sort command is actually under the list menu because you're going to sort one of your lists. So I'll press second stat to get to that list menu. And I'll go over to operations. And my first option is sort A, or sort in ascending order. So I'll select that. From there, I've got to tell it what to sort. Well, I wanted to sort my x's into numerical order. So I need to go get my list called Dem 80. Fastest way to do that is again through the list menu, so second stat. And this time I want to search down through my names until I find the list called Dem 80. And so we'll see here that Dem 80 is option number 8. So we'll choose that one. I do want to put a comma here and then also add in Dem 84 right afterwards because I don't want it to just sort the first column. I want it to sort the first column but keep its relationship to the second column. So I'll choose Dem 84. And then I will close my parentheses. So I'm having it sort based on the first column but keep its relationship to the second column, and press enter. Seems kind of underwhelming. Seems like nothing miraculous happened. But now when I go back and check my table, which is under Stat, Edit, now all of my data is sorted in ascending order, starting with or using Dem 80 to sort. So what? What am I actually looking for here? In order for this to be a function, every x value, which is what we're seeing here in this first column, must have only one y value. So what I'm really looking for is, are there any repeated x values that don't have the same y value? So I'm just scrolling, just checking it out. I mean, this is a lot easier to look at than what we were looking at a minute ago. And then, oops, there's 38.2 twice. And we'll notice that it has different y values. And so for one particular input value, we get two outputs, and that contradicts the definition, of a function, meaning that this is not a function, which is kind of what we were thinking when we were looking at the graph. So wanted to start by showing this. And again, two big ideas here. How could we use graphs and drawing a vertical line on the graph to determine functionality? And then how can we use tables to determine functionality? But how can we sort our tables so that they're a little bit more user-friendly when we're dealing with big data sets or real-world functions or real-world situations? So from there, I kind of mentioned that there were 3 different problems in this activity. So that was just problem number 1. Here's a screenshot of the data from the second problem, which looks at height versus age. So less less data points, more of a pattern, but students could do the same analysis. They could use a vertical line and see if there are any points that have two outputs for one input. Then they could also check the table and sort the table to see if there are any contradictory points there as well. So wanted to start with that piece. Toni, any questions or comments to interject before we look at a corresponding Nspire activity?
Not that I can tell, Michelle.
Okay, perfect. And we'll go ahead and move on. But again, if you have questions or comments, please feel free to type those in the chat, and you want to send them to all participants so that we can see them as well, or enter them in the Q&A section. So now we'll look at an Nspire activity called definition of functions. And even if you don't have the Nspire, use the Nspire, we can look at some ways that this activity builds this content piece as well. So this particular activity, go ahead and pull it up. Again, has a student activity page and a teacher notes page. And on the student activity page, it gives students a particular set of ordered pairs that they're supposed to kind of investigate in terms of functionality. So one of the first ordered pairs is 0, 1. And what students will do is go over to this point and drag the point onto the graph. And the first point was 0, 1. So they'll place the point on the correct position on the coordinate plane here. You'll notice a number of things happened. The coordinates of that point popped up at the bottom, and also there's a mapping over here on the right. So there's some questions for students to consider on the student activity. How do you know that you plotted the point correctly? So they can kind of check down here. They can also check their input-output. And then describe what the arrow in the table represents. So they could discuss here about how your input value of 0 is mapped upwards to an output value of 1. So from there, they have to plot the remaining points in the particular set of ordered pairs that they were given. So then there's a point of 1, 2, there's a point of 2, 4, there's a point of 3, 3. And again, I'm leaving these just off of the student activity. And then the final point is 4, 5. And so then as those points are plotted, they can confirm them across the bottom and notice the mapping as well. So then students are charged with determining whether or not they think this set of ordered pairs constitutes a function. And again, our definition was that for every given input value, there's only one output value. So looking at the graph, that looks good. It looks like it would pass a vertical line test. Looking at the mapping, it looks good. Each input is only going to one output. Doesn't matter that these two arrows cross, and so students might think that this is a function. So once they kind of made their prediction, they can go down here and use this slider to actually test whether or not this is a function. So I'm going to click on that slider, and I get the feedback that yes, this is a function. So then they'll move on to the next set of ordered pairs and kind of investigate it. So say we had a function, or a set of ordered pairs where maybe this was our resulting mapping over here and graph here. And say this time students were thinking, you know what, I don't think this is a function because for this input there are two outputs. You can see that on the mapping here as well, where one input is sent to two different places. Now when they do the function test, they'll see that it's not a function, and there's a line drawn on the graph and a circle added to the mapping that shows the x value that's problematic, that's showing for what input value there are two outputs, which makes this not a function. So it's kind of a neat setup there for students to practice some different skills, but also get some immediate feedback on whether or not something is or isn't a function. The other thing you'll notice is there's a reset slider up top that they can use, and that will quickly reset the whole page so they can start on their next set of ordered pairs. Then at the end of this activity, students are charged with creating a relationship using points, so they can drag them from over here again, create a relationship between sets A and B that is a function, and then create another one that's not a function. And then they're going to share those with a partner and try them out on each other's handhelds to determine whether or not they were able to create relations that were functions or weren't functions. So a great little activity that brings together a lot of those big content ideas. And remember in this standard that this particular standard looked at different representations, determining functionality using sets of ordered pairs, tables, mappings, and graphs. And so between these two different activities, we see a lot of those different multiple representations to really build that understanding. So I'm going to turn it back over to Toni, who's going to talk about the next standard we're going to look at, which comes from Algebra 1.
Thank you, Michelle. Great job. Let's look at A4A, which is going to be new to Algebra 1 when we implement the revised TEKS next year. And this is calculate using technology the correlation coefficient between two quantitative variables and interpret this quantity as a measure of the strength of the linear association. So we're going to be calculating R. This is a formula that you don't want to calculate by hand. It's a monster formula, but notice it specifically says using technology. And so we're going to look at how you can do that and find the value of R, which is going to be somewhere between -1 and 1. And we're going to use it to measure the strength of the linear association. And so students are still going to be expected to use the language of positive, negative, and no correlation as they describe the strength of the linear association, but they're also going to be asked to calculate the correlation coefficient R. And so we're going to look at some activities on the 84 and the Nspire that do that. So we have one activity called Does a Correlation Exist for the 84 as well as for the Nspire. And so both calculators will actually calculate R for you, and that's what we're going to look at tonight. So Michelle, if you'll take us through those activities.
Okay, perfect. Thanks, Toni. Let me kind of get reoriented here. So we're going to start by looking at the 84 version of this activity called Does a Correlation Exist? And the idea of finding linear regressions is not new to Algebra 1. That's something that we've done for years in Texas. But this idea of adding on the correlation coefficients to determine how strong that association is, that part's new. And so that's what we're going to specifically look at. So let me move the 84 emulator back over. And you'll notice that we switched over to the 84 plus C for this part, and then we'll kind of switch back for the next activity. So here, just to kind of give you an idea of what's going on so far, we've run a program that has entered some data into a list for us. And so this is the data we're looking at here. And just to give you the context, L1 tells us the selling price of houses in hundreds of dollars. So for example, that first data point there is actually $205,000 for that house price. And then in L2, we're actually seeing the square footage of that house. And so then we'll have a discussion about, okay, so if we're comparing selling price of the house or sales price and square footage, which variable would be independent and which variable would be dependent? Does the square footage depend on the price? If you sell your house for more, then your house has more square feet. It just grows bigger. Or does sales price more likely depend on square footage? The bigger your house is, the more money it will likely sell for. So once we've got that set up, we went ahead and set up a stat plot. Again, this part is not new to Algebra 1, so we won't go through the details. But you'll notice here that we determined that L2 was our independent variable. And so we put that in as our X list, and then our Y list will be L1 in this particular instance. And then we'll do a zoom stat to be able to see our data, and that's where we're at now. So this idea of being able to do the stat plot and then this next step of doing a linear regression is not particularly new, but we'll get to the new piece here in just a minute. So if we're going to go ahead and do this linear regression, we would go to the stat menu, over to calc, and then our fourth option down is a linear regression. And so then it's going to ask us where are your X's, and in our case, they were in L2. Where are your Y's? In our case, they're in L1. And I'm just using second 1 and second 2 to call up L1 and L2. Now, another handy trick here is I want to store my regression equation. In case it comes back where it's kind of messy, it has lots of decimals, things like that, I want it to automatically go to Y1, so I don't have to type it out again. With the updated operating system, you can actually push alpha trace and get quick access to all of your y equals. So like I want my y1, for example, my y variable y1. I'll select that one, and that copies and pastes it right there so that this equation is stored as y1. Now I'll go down and calculate. So then you'll see that it runs the linear regression. It gives us our A and B. Again, these are not precise or not exact numbers, so I'm glad that it actually saved this over to y1 for me, put in my regression equation. And now we'll see it, that regression equation on the graph as well. So all of this has been done in Algebra 1 before. So our question really then is, how do I get my R value or my R squared value? And there's one thing we have to actually turn on first in order for that to show up. So it's under your mode, or if you push mode, it'll be under your mode options. And this is what you'll see on your mode screen for the TI-84 Plus color. The TI-84 Plus will actually have 2 pages, and you'll have to scroll to the second page to see what we're looking for. But what we're looking for here, all the way down near the bottom, there's an option called Stat Diagnostics, which is currently turned off, but I want to go ahead and turn that on. Now when I do that, I'm going to quit out of the mode. If I run my regression again, so I could go Stat, over to Calc, down to number 4, LinReg. I'm still going to use L2 for my X, L1 for my Y. Store my regression equation in Y1, so I'll do alpha trace for that hotkey to choose Y1, and then calculate. And this time you'll notice when the regression runs that we now have our R squared and R values showing up on the regression as well. Whereas before we didn't have access to those. So all we need to do to be able to see those is make sure we go to mode and turn our stat diagnostics on so that we can look at those. So here we have an R value of 0.676. It's not terrible, not wonderful. Again, as Toni said, the closer that R value is to +1, the stronger the positive linear correlation. The closer it is to -1, the stronger the negative linear correlation. The closer it is to 0, it means not really linear at all. So wanted to mention that piece. The other thing we can do is now when we go over to our graph, we'll notice our regression equation is graphed here again because we saved it in Y1. We can use trace to look at either our plot, our stat plot, or our regression equation. But we'll notice here that the sign of our slope, so in this case positive 0.517, matches with the sign of our R value. So our R value is positive 0.6 something. So a positive slope and a positive R value correlate, versus if we had a negative model, our R value would come out negative. So wanted to show those 2 features on the 84. And also mention that this is another activity that then has 2 additional problems for students to look into. So the next problem looks at teacher salary and student spending. Is there a relationship between those 2 variables, and is it linear, and how linear? And then problem 3 looks at latitude and temperature in January, and what might that relationship look like? So those are all built into the student activity called Does a Correlation Exist? Toni, any comments or questions on the 84 version before we switch over to the Nspire version?
No, Michelle, that was a great explanation. Thank you.
Yeah.
Hey, Michelle, actually I do have one quick question from Jennifer.
Sure.
She wanted to know if the specific keystrokes needed to access things like sorting a list on the TI-84 are available as part of the activity sheets.
Perfect. Yes, so that's a great question. And so both on either the student activity or on the teacher notes, it will walk through step by step the exact keystrokes that we're doing. So it will even walk through, for example, when we're doing this stat LinReg, it will even walk through that little shortcut of pushing alpha trace to get your Y bars that quickly. So yes, all of those keystrokes are there either on the student version if it's walking kids through it, or on the teacher version if it's more supposed to be teacher-led. So great question.
Thanks.
Yeah. Okay, let me move that out of the way for a second. Okay, so then moving on to the Nspire version of this activity. Pull that one up. So very similar activity, just has a different student activity and teacher notes for walking through the Nspire version instead. And so here you'll notice in this Nspire file that we're on a spreadsheet page. And here's my same data from before. There's that house that sold for $205,000 and has 2,650 square feet. But on Nspire, you'll notice that we're now able to name those columns or those data sets with their actual kind of in-context names. So what we'll do here is, given this data set, we're going to move to page 1.5 and go ahead and create a scatter plot of this data. So we talked about square feet being the independent variable, I believe, and price being the dependent variable, so we can select those. Again, if you're an Nspire user teaching Algebra 1, this ability to do the scatter plot, et cetera, that's something we've been able to do, we've done a lot of. But now we want to look at, okay, so how do you get the correlation coefficient? How do you find R? So a couple ways that you can do that we want to model. One way is actually on a calculator page. And that's something that Toni and I talked about, man, we rarely do this on a calculator page, but we both really like what this looks like here. So let me model this. You'll notice that, again, we've already got our data in on 1.4. We've got our data and statistics, our scatter plot graphed. And now we want to actually do a linear regression on a calculator page of all things. So from the menu, we'll choose option number 6 for statistics. And within statistics, there is our stat calculations, much like on the 84, how we went to stat and then over to calc. So under stat calculations, we can run a linear regression mx plus b. So I'll choose that option. Wants to know what's your x list. So we can go in and choose our variable. Our square feet were our x variable. Our y list was price. And then save regression equation, it's automatically going to save it to F1, which sounds perfect. So then from there, we'll go, okay. So right away, it goes ahead and runs a linear regression. And you'll see here's my slope, here's my y-intercept, here's my r-squared value, here's my r, 0.844, et cetera. So this is a much stronger linear association than we're seeing before. But if we go back to the to our graph, we could also graph that equation here. So if we'll go to the menu, and then down to analyze, to regression, and then show linear. So this is something that if you've used the Nspire, you've maybe done a number of times, being able to show that regression equation on a data and statistics page. The problem is we can't see the R value on this particular page. And so that's why we would want to run a regression on something like a calculator page so we can really get that correlation coefficient to think about how strong that association is. A couple other things that we wanted to model here were things like this. So on page 1.5, because the Nspire is a dynamic software, we can actually change these points, like live time. And so we might say, okay, well, what would make this a better linear correlation, a stronger correlation? Right now, we have an R value of 0.844. How could we make that closer to +1? So we could go into our graph and actually just kind of grab some points and move them closer. We're totally, cheating here and moving data. But what we're doing is exploring, what is the R value? How do you change the R value? How do you, will this make a difference? So I'm just kind of moving some points around, moving them closer to that line of best fit. And now when I go back to 1.6, and I'm going to go arrow up twice to run my regression again, now you'll notice that my R value is 0.927. And so I have a stronger positive linear correlation this time. And so it's kind of a neat way for students to explore what R is really telling us and what it means. One other thing we wanted to model was finding the linear regression on the calculator page is not the only way. It is kind of an easy way, but there's another place you can run that regression as well. It's not on the data and statistics page, but instead it's actually back on your spreadsheet page. So I'm going to arrow over to an empty cell, say C1. And once I'm in that empty cell, I'll go Menu, Statistics, stat calculations, just like I did on the calculator page, and then linear regression mx plus b. I'll have the same options. Where are your x's? In our case, they were square feet. Where are your y's? They were under price. Save regression equation to F2 this time because I've already used F1. And I'll go OK. So then you'll see that it creates right inside the spreadsheet that same regression equation with m, b, r squared, and r. One of the things that we like about kind of doing this in the spreadsheet instead of in the calculator page is watch this. Right now my R value is 0.927. I'm going to go over to my data and statistics page and do some more of that manipulating. Move some of these points closer. Kind of cheating with that data a little bit, but making a bit more stronger linear correlation maybe. Now when I go back to my spreadsheet, list and spreadsheet, you'll notice that my R value automatically updated. I didn't have to run that regression again like I had to on the calculator page. So just wanted to show both of those options for ways that you can run a regression and get your correlation coefficient on the Nspire. And again, this activity then works through two additional problems, the same two problems actually as the 84 activity, looking at teacher salary and student spending, and also latitude and temperature in January. So Toni, why don't we talk about, or move on from this one, unless there are questions about correlation on the Nspire, then we can pause on those. So see if there's any questions, and then we'll talk about solving systems.
Okay, that was great, Michelle. I'm seeing a lot in the chat window, but I haven't seen any specific questions. Mike, have you seen any?
I haven't, so I think we're good to keep rolling.
Okay, thanks.
We're going to go back to 8th grade, and Toni's going to talk us through another new standard that's moved down to 8th grade.
Okay, thank you, Michelle. We're going to look at 8.9a, which is identify and verify the values of x and y that simultaneously satisfy two linear equations in the form y equal mx plus b from the intersections of the graphed equations. And so this is going to serve as an introductory element for systems of equations, and it also reinforces for students that two linear functions may be considered simultaneously. And so I think the focus is on the identification of the intersection point and then verifying that it satisfies both linear equations. So this is brand new for 8th grade. We're moving systems of equations down. They're not going to be asked to solve systems algebraically, but they are going to be asked to find that solution graphically and then to verify that solution. So let's look at some activities that will help do that. So we have two activities. The one for the 84 is understanding solutions of systems using tables and graphs. And then we have one for the Nspire, which is solving systems by graphing. So Michelle, if you'll take us through those two activities.
Okay, perfect. So starting with the 84 version, as Toni said, we're just looking at solving systems graphically, and then we'll use the tables kind of as a support mechanism, if you will. We're not going to have to do these algebraically in 8th grade. So let me move the emulator back over. And in this particular student activity, it's a very short activity, just 2 pages. It starts by having students graph this particular system. And so they'll enter these two equations into y equals. And then they have to set up a particular window, and so I'll just give you a preview of that. And you'll notice that our window here is going to go over by 2, and we're seeing that in our x scale, and then also go up and down by 2. So now when I push graph, here's kind of a graphical representation of this particular system. So this activity walks students through 3 different ways to solve this system using the graph. So way 1, or method 1, is using trace. So if I push trace, you'll notice that it brings up my function in the upper left and then the point that I'm on in that particular function. And I can trace left and right looking for, trying to get close to that point that is common to both equations. And so I'll trace over in that direction, and it kind of looks like it's somewhere around here, maybe 8, maybe 8.4. If I want to check and see which one it is, right now I'm on Y1, but I can push the up or down arrow to change to Y2. So at 8.4, I'm at 7.2 on this function. When I switched to Y2, 8.4 is at 7.8. So that wasn't exactly right. So if I move back at 8, I'm at 7 for my output on Y2, change back to Y1, 8, 7. So it looks like that is the point that is common to both of those lines. So really building this idea that the solution is, excuse me, for at least a system of linear equations is the one point that both lines have in common. One other thing I'll mention here, just as it's a really neat feature when you're tracing, say I was over here and I wanted to jump to the point x equals 8. Or say I was over at 8 and my next step was going to take me to 8.4, and instead I wanted to be at 8.2. How do I get my trace to go to a particular x value? So one thing you can do, and it doesn't look like you can do it, but you can just start typing in, is I'm going to type in the x value 8.2. And all I did was just start typing the number. So it shows up x equals 8.2, push enter, and it will jump to that particular point on the graph. So say I wanted to jump over to -4, I can just type in -4 for x, and it will jump over to where the graph is there. So again, that works if you have your trace turned on. You can just type in x values, and it will jump around the graph to those particular x values, which is really kind of a handy feature. We'll also look at what this table is showing us. So if I go to the table, we'll notice that this particular table starts at 0 and goes up in increments of 1 for our x's. And what are we looking for here? Well, we're looking for, is there a common point? Is there an x value where the y values are the same? And we'll notice that when x equals 8, the y values are both 7. Which kind of makes sense when we think about the graph we just saw. 8, 7 was that common point to both equations. That's the solution of our system. And so here we're looking at another way to think about that, or to back that up with a table representation. Last thing we'll look at is kind of method 2 for solving this system using tables or graphs. The third way, back on the graph screen, is to use the intersection command. And so you can find that under the calculate button for graphing. So we'll do second trace to go to our calculate menu. And then we have the option to find the intersection, option number 5. When we select that, we're going to be walked through a number of different options. And I'm actually going to just arrow over to the left here just so my cursor's not kind of right on top of that point. The first question it asks me is, what's your first curve? And we want it to be y1, which is what it's on right now. So I'll push enter. Then it wants to know, okay, so is this your second curve, y2? Why is it asking this? We may have more than 2 equations graphed. We might have 3 or 4 or 5 equations graphed, and it wants to know which ones we're looking to find the intersection of. So I'll push enter to choose that one. And then it wants to kind of know about where these cross. So we can get close, maybe even just this close, and push enter. And then it will find that intersection point. I think I clicked too soon, sorry. Let me do this again. So first curve, second curve, yes. It will find that intersection point and show us those coordinates down at the bottom, 8, 7. And so that's another way that we can find the intersection or the solution to a system of equations using the 84. Okay, so thoughts or comments on that?
It looks great, Michelle. Let's see what it looks like on the Nspire.
Okay. So kind of a complementary activity on the Nspire is called Solving Systems by Graphing. Again, only looking at the graphing perspective here for the 8th grade. Let me pull up this activity. Great little activity that we really love, where kids can kind of explore what it means for something to be the solution to a system. So in this case, they're given a file, or in this file, they're given 2 graphs. So we have y equals x plus 1, y equals negative x plus 3. And you'll notice that a trace is set up to show corresponding points on those 2 lines that have the same x value. I can actually grab this point on the x-axis, and as I move it along, it's going to trace along those 2 lines and show the coordinates. So one of the first questions says, move the point so that x equals negative 2. And then it says, is either of these ordered pairs a solution to the given system? Why or why not? And so this is a solution to the first equation. This is a solution to the second equation, but they're not solutions to both, and so it's not a solution to our system. Then they're supposed to move this point over to what about x equals 3? Is that a solution? Same problem. They're each a solution to one, but not a solution to the other. So from there, they're kind of charged with, okay, so go ahead and find the point that you think is the solution. And as they drag across, there's just that one common point where the two overlap at 1, 3. I'm sorry, 1, 2, and then they'll look at why that is the solution to the system, and then they'll check that algebraically. So they can plug in 1 to this first equation and verify that you get 2 as your output. Substitute 1 into the second equation, again verify that you get 2 as your output. So that point is common to both equations. Now, one other thing we wanted to show kind of on this page is you still have the ability to find the intersection using calculator tools. So we could go to the menu and go to Analyze Graph, Intersection. My clues are down here of what I'm supposed to do. There's lower bound, so be on the left of where that intersection point is. Click. Now it wants the upper bound, so I'm going to stretch across that point of intersection and click, and then my intersection point will be highlighted. So that ability to calculate the intersection point is available on both the 84 and the Nspire. This activity continues from there and has students consider other systems. So two classmates each kind of generate other systems that they think also have solutions of 1, 2, and then students are supposed to kind of check those out and see if they work. So one such system is x plus 1 and 4x minus 2. So they can go in and change the second equation to 4x minus 2, and then see if the solution is still 1, 2. And then there's a number of other questions that have students test out and use the graph to figure out what the solution is to the system, and then to verify that algebraically. Okay.
Great job, Michelle. Thank you.
So we're kind of coming to the end of our time together. We want to show you a couple other standards that we've pulled activities for. And again, you'll have the links for all of these that you can then explore on your own as well. And so quadratic functions is going to be a much more prevalent part of Algebra 1 when our high school standards change here in a year. So students will have a lot more that they need to do with quadratic functions and to a much deeper level. And so you'll find in the corresponding handout that you'll receive two activities, one for the 84 and one for the Nspire, that kind of deal with building these solid understandings of quadratic functions, both in terms of the 4 types of transformations that students now need to know, which is already the standard. 2 of these transformations are new now to Algebra 1. They were not previously covered in Algebra 1. And these 2 activities also look at finding key attributes for quadratics using reasoning instead of just using calculator tools per se. So what does it mean for something to be the vertex? What does parabola being truly symmetric mean? What does that tell you? Things like that. So there are a couple activities for you to look at there. And then also we pulled some activities for finding the distance between points using the Pythagorean theorem. Some great little explorations on both the 84 and the Nspire for like where that distance formula, air quotes, comes from. 8th grade does not need to use the distance formula. They just need to use Pythagorean theorem and that idea to find distance between 2 points on the coordinate plane. But that's new to 8th grade. And then the last thing we wanted to kind of mention was exponential functions, which is a huge new part of Algebra 1. Used to be a very minor part of Algebra 1, but now it has an entire reporting category. And so we found some great little activities that can also bring home those ideas about exponential functions, a little bit on what does it mean, what are the different parts of an exponential function, what is the common ratio, where does that come from, some of those kind of things. And so we pulled a couple activities for the 84 and the Nspire for that as well that you can look at and explore from the resources that Mike will be sharing with you. So Toni, any final comments as we begin to wrap up and begin to take questions?
No, Michelle, you did a great job of giving us an overview of some of the free resources that teachers will be able to take advantage of with these new shifts in content with the revised TEKS. Thank you.
Yeah, no problem. So we will kind of transition into a time for questions. If you want to share questions in the chat, sending them to all participants, or you can share questions in the Q&A section. And then I know Mike has some exciting things to share with us too about different professional development opportunities that are coming to Texas and some really cool deals on those as well.
Thanks, Michelle. I think we're 2 questions at least I could see a little back a ways in the chat that might not have been answered, and so I was hoping maybe one of you two could shed some light on it. The first question was mentioning that you might be using a newer operating system with your TI-84 than what maybe someone else is. And so if they go ahead and update their TI-84 operating system, will that affect any of their lists or programs that they currently have stored in their TI-84?
That's a great question that I don't know the immediate answer to. I guess I've never updated it with things in it. I'm not sure, Toni, if you know the answer to that, but it may be that we're using the newer operating system because that ability to do like the alpha trace to bring up the Y1, Y2, kind of those shortcut hotkeys is part of that newer operating system. Also things like fraction templates and math print are part of that same operating system. So definitely worth the update, but I'm not sure off the top of my head whether those lists, et cetera, stay. Toni, do you know?
I'm with you, Michelle. I'm not sure either. I know when we do update our operating systems, it always tells us to make sure that we have things backed up. So that could be a possibility, but I'm not sure either.
I think Johnny mentioned that if you archive things, which can be done in your memory, if you archive things, you should be okay. The second question that I didn't know the answer to was from Lily, and the question was, let me scroll up, are they on Leeward already? And I'm guessing that was for the 2015-16 TEKS for Algebra 1.
Yes, actually the revised TEKS, kindergarten through high school, are both on the TEA website under STAR Resources, and also Lead Forward already has them on their website as well.